Good. Number 6, perfect. In number 6, we have 3 equals log base b of 27. Perfect. Good. They want us to change it into an exponential. Of course, it's a log equation. Write it in the correct form. Log base b of 27 is 3. How do I change this into an exponential? Where is the starting point? How do I write it? It's always counterclockwise, and we always start with the base.
Three rise of
Careful. B. We always start with B. B.
Rise of 3
Yes.
equals 27.
Good. Which number raised to the third power equals 27? We're not asked to solve it. We are just asked to, but what if we are also asked to solve it? Can we figure it out?
Three.
Indeed. 3 to the third power is 27. We were not asked to do this. I just wanted because it was so easy. Good. Do we need to look at another from 1 through 8? If not, we move on to 9 through 20. Anyone?
Can we do number 7?
Yes. There's number 7 as well. Very good. Log base 6 of 216 is y. Perfect. Let's convert it. If we can solve it, we will. So how do I convert this?
Six rise to y equals 216.
Yes, indeed. So you can check. 6 to the second power will be 36. 6 to the third is to 16. So if you want to solve it, there is no need right now, but y equals 3. Good. Nine through 20.
Can we do number 13?
Yes. Let's do number 13. Perfect. And this is page 10. And 13 we have, you said 13, right? No. Did you say 13?
Yeah, I said 13.
Okay, good. The cube root of 8 equals 2. Perfect. What I highly recommend is write the relationship. What is the relationship? Log base b of x equals y is equivalent to b raised to y equals x. Okay, so what am I going to do next? This is exponential, so I'm on this side. The base is 8. The power is 1/3. And the number is 2. So there is no log here. Obviously, this is exponential. Obviously, 8 is the base. Obviously, the power is 1/3 because that's the cube root. the equal symbol, and then 2. And now I figure out the left-hand side. I put the equivalent symbol, the double equivalency. I put log. Remember, this must be the base. Well, what is the base? 8. I am raising 8 to this number, to y. Well, what am I raising it to? 1/3. And the answer is 2. 8 to 1/3 is 2. So it may be, at least at first, a little bit more difficult to start with an exponential and come up with a log. Write the relationship, identify the base, identify the power, identify x, and then it's very easy to convert it and just put the numbers in here. 8 to 1/3 equals 2. Okay, let's choose another, maybe more than one. Converting back to log, maybe slightly more challenging if you want, but once we write the relationship, we should be fine. We should be always able to convert everything. Let's choose. Which one? From 9 to 20, do we want to practice another or we move on?
Can we do 19?
Yes, of course. Let's look at 19. In 19, we have 7 raised to y equals 200. Perfect. Again, I'm going to write the relationship. Log base b of x is y is equivalent to b raised to y equals x. Very simple. 7 raised to y equals 200. I have log. I need to find the base. I need to find here x, and I need to find here y. The base is here, x is here, y is here. Can anyone identify them? Let's start with the base. What is the base?
Is it 7?
Indeed. What do I raise it to?
Y?
Indeed. And what is the answer? Of course, I have 2 of them. The other one must be 200. Indeed. 7 raised to y equals 200. Very good. Now, before we move on to the next set of problems, I want to tell you that log has properties that no other function has. 4 properties of log. They're basically 3 plus 1. I'll explain. First property. No other function ever has these properties. Number 1. If I have log in any base of a product, x times y, 2 times 5, any product, this converts into a sum of logs and backwards as well. If I have log of a, again, they have to have the same base. 5, 5, 5, 10, 10, 10, e, doesn't matter, but the same base. So log of a plus log of b is log of the product of these two. Log of the product is the sum of the two logs. What if I have 3 factors times c? Fine. Log of a plus log of b plus log of c. So this is called the product rule because it's a product. No other function has this property. Here's property number 2. Log applied to a ratio. The same thing, but with minus. From the top, minus the one is at the bottom. Of course, back and forth. If I have 2 logs with the same base and they're subtracted one from the other, this one comes from the denominator and this one comes from the numerator. Of course, this is called the quotient rule. Notice that I'm not saying log of A over log of B. No. I'm saying log applied to a ratio. Not log of A over log of B. It's log applied to the ratio A over B. This is the difference between log of the top and the log of the bottom. Property 3. Log base B of x to a power. Anything to a power. The power goes in front as a factor, meaning multiplies log. Of course, this is the power rule. So log applied to an expression with a power. The power can be brought down in front of the log and multiplies. It's a factor, multiplies log. The last one, it's basically called the change of base. Formula. Notice that basically calculators have the log and the natural log. Now I'll show you these fancy calculators allow us to punch in any base. But let's understand the change of base formula. Let's say I have log base 3 of 11. I don't know what this is. I don't know what I raised 3 to get 11. No, I can't. So again, this is like 3 raised to y equals 11. Do I know what this is? No. I know it has to be more than 2 because 3 squared is 9. But what is it? I have no clue. So in order to determine this, I would have to change the base. To which base? To either natural log or common log, base 10 or base e, to determine this number. So how do I do that? Now it's a ratio. Now it's a ratio. A ratio of log of the number at the top and log of the previous base in the denominator. I have to use the same log. You can use this, and you can say, why don't you use natural log? Fine. Natural log of 11 over natural log of 3. This number has to equal this number, has to equal this number. So let's take a look. So, natural log 11 close divided by natural log of 3. This number has to equal the same log of 11 divided by log of 3. They have to be identical. And the graphing calculator has a feature now. I never use it. Here it is. Log base 3 of 11. It has to be an identical number. So you either use the change of base formula with natural log over natural log, or with common log over common log, or you use the calculator feature in math all the way up to 0, I think it is. No, A, log base. Okay? Any of those will give you the same answer. Okay, now we are ready for anything you'd like to pick from 21 to 42.
$34.
34, let's start with 34, very good. 34, where are you, 34? I see it. Very good, excellent. 34 is log base 81 of 9. It says use out without using a calculator, fine. So I don't know what this is, but I know how to convert it. Can anyone help us convert this from a log equation into an exponential equation? Can anyone tell us how to write it? I mean, we use this so many times today. I'm sure you're going to dream about it.
$81 raised to y equals 9.
Excellent. Very good. 81 raised to y equals 9. So, now, how do I solve this? Because I don't have the same base. If the left-hand side were, let's say, 9 to y and the other side is 9, then I will know y equals 1. But it's not the same. But can I change this maybe into 9 to some power? Nine to which power is 81?
Nine raised to 2.
Very good. Copy the base, multiply the exponents. So then I know 2y must be 1. There is no other way. So if 2y equals 1, then y equals 1/2. Now, can I check this? Yes. Either with the change of base formula or with a feature in the calculator, and we have to get 0.5. So if you want to copy this, then I will put in the base 81. I will insert and then delete the 3. And then this is 9. So when I hit enter, I have to get 0.5. If I don't get 0.5, something is wrong. Or you use the change of base formula, which is natural log 9 divided by natural log 81. And the answer has to be the same. Good. Let's choose another. Any questions? Any questions? Do we want to choose anything else?
Can we do 30?
Yes. Let's look at 30. Perfect. 30, 30, 30. Very good. Log base 6 of the square root of 6. Perfect. I have no idea what this is, but I can always convert it from a log equation into an exponential one. How do I do that for this? Can anyone convert it for us so we can find the answer?
6 raised to y equals square root of 6.
Very good. So this is 6 raised to y, and this is 6 raised to which power? The square root of 6 is 6 raised to the square root of 6 is 6 raised to which power?
One.
It's 1/2, right? It's the square root. So the square root is the same with power 1/2. Good. So then how much is y? The only possible number. 6 to a number equals 6 to 1/2. What should that number be? Can this be 5? No. 6 to the 5th power cannot equal 6 to 1/2. Can it be -3? No. 6 to -3 cannot equal 6 to 1/2. So what is the only option? Anyone, please? Six to what number is 6 to 1/2? What do you think?
Would it be 0.5?
Indeed, 1/2. There is no other way. These have to be the same. There is no other possibility. But 6 to which number is 6 to 1/2? It has to be 1/2. 6 to 1/2 equals 6 to 1/2. Indeed. Do we need another example or can we continue?
Can we do 32?
Yes. Very good. Let's look at 32. 32. Log base 64 of 8. 32 log base 64 of 8 is what? 64, 32, 30, 33. Yes. Oh, you said 33 or 32. I started writing and you said 30.
32.
You said 32. I copied 33, of course. Log base 3. We're going to do both of them now. And 32, and this is 33. Sorry about that. Thinking of my next step. Okay, good. I have no idea what this is, but I know how to convert it. How do I convert log base 3? This is the one, right? Did I copy this, the correct one now?
Yes.
Thank you, Christy. Okay, so I have no idea what this is, but I know how to convert it, and then I'll think about it. How do I convert it? Once I convert it, it will give me an idea how to proceed. But I have to convert it first. Can anyone help with the conversion?
Three raised to y equals 1 over the square root of 3.
Good. I cannot do anything to 3 to y, but I have to rearrange this as 3 to which power? which power gives us 1 over the square root of 3? Let's start with the square root of 3. So the square root of 3 is 3 to which power? We used it a few minutes ago.
1/2.
Yes. But since it is in the denominator, then what will be the power? I cannot put 1/2 because it will not go to the denominator. It will stay at the top. So I have to put what?
0.5.
But negative. Negative. Otherwise, it will not go to the denominator, right? So a to negative n is 1 over a to the nth power. So if it's in the denominator and I want to bring it back up, it has to be raised to a negative exponent. 3 to negative 1/2 is 1 over the square root of 3. Is this okay with everyone? Give me a sign. Is it a yes? Is there a no?
Yes.
Perfect. And now let's identify y. So then y equals,
Is it negative 1/2?
of course, there is no other way. If the bases are the same, the exponent and the numbers are equal, the exponents must be the same, indeed. Good. I'd like to continue with, as you know, this function is not friendly. I'd like to continue with domain. Find the domain of each log function. This is very important. From 75 to 80. Okay? From 75 to 80. So just give me 1 second. I need to mute you. It's nothing personal, but there is a noise. That's okay. There is noise in the background. Sorry about that. No problem. Find the domain of each logarithmic function from 75 through 80. And I'll explain why this is so important. Allow me to choose the first one and then you choose the next one. So 75. So I have f of x equals log base 5 of x plus 4. So let me see the time here. Okay.